Section 5, question 11. A function f is given by f of x equals the square root of 9 minus x squared. What's a suitable domain of f? A, b, c or d? This is a question that's combining functions with another topic, which we'll find out in a wee second. Domain refers to numbers that can be inputted into the function. So that's basically our x values. Now, suitable domain just means what x values are okay to go into the function. You can find the suitable domain by finding the restrictions on the domain. So if you find a restriction on the domain, what you're implying is that everything else is suitable. Now, what I would say about this one, square root of 9 minus x squared. In terms of x values that would be suitable here, what wouldn't be suitable is anything that would give me the square root of a negative number. So this thing in here, we couldn't have that being a negative number. So the notion that 9 minus x squared is less than 0 is the one that I'm looking to explore. And whatever x values that I get from that, those would be ones that would be restrictions on the domain. Now what we can see now is this has turned into a quadratic inequality. And to solve a quadratic inequality, we need to make a sketch. So the first thing that I would say is it's a negative x squared, which means it's an upside down U-shaped parabola. I'm now going to find my roots by making the function equal to 0. And I can do a difference to squares here, so it's going to be 3 plus x bracket 3 minus x. That will then give me a root of x equals 3 and a root of x equals minus 3. I know that it's a upside down U-shaped parabola, so that's what that will look like. Now, if I go back to the original thing, square root of 9 is minus x squared. Now, what we can't have is we can't have that thing inside there, inside the square root sign, is a negative number. So 9 minus x squared cannot be less than 0. So where it's less than 0 is, you can see pretty clearly, down here and down here. So what would be okay then is when it's equal to 0 or greater than 0. So we would say a suitable domain would be up here. So that's between and including minus 3 and 3. And that is option C. Section 5, question 12. The curve with equation y equals log to the base 3 of x minus 1 minus 2.2, where x is greater than 1, cuts the x-axis at the point A0. Find the value of a. Well, a is just the x coordinate, so we're looking to find the value of x. Now, what's true on the x-axis is y is equal to 0. So I'm going to make the equation equal to 0. So I've got log to the base 3 of x minus 1 minus 2.2 is equal to 0. If I then bring the minus 2.2 across, I'll get log to the base 3 of x minus 1 is equal to 2.2. I'm then going to do my loop, which is 3 to the power 2.2 is equal to x minus 1. So that will give me x minus 1 is equal to 11.2 to 1 decimal place. Bring the minus 1 over and x will be equal to 12.2. And that's the final answer.